Hello again to the next part of our lectures, and this time I'm going to be talking about the follow-up to the previous data distribution lecture, and this time I'm going to talk about peer-to-peer networks. Some of the systems that I put on the slide, I guess you already seen before, and I'm specifically talking about the BitTorrent. Besides the BitTorrent, there's a bunch of other protocols, and in general, you can classify peer-to-peer networks in two very big categories. So one of them is unstructured peer-to-peer networks, and BitTorrent is one of them. But there's also so-called structured peer-to-peer networks. And there's a classic Quart, and there's several others, and for example, there's also Kademlia. The key difference between these two architectures is with unstructured, they're just a set of nodes that can act as a client and server, and there's no, from the peer-to-peer network itself, there's no requirement of any kind of state that those nodes needs to maintain. And for example, in BitTorrent, you can join the so-called swarm of others and start downloading Linux distribution. You can leave anytime, you can start sharing, you can kind of stop sharing. There's several reasons you may want to keep sharing, but in any case, you can stop at any point of time, and nobody would care too much, except maybe going to become a little bit sad that there is not enough capacity, but the system will survive. Like as long as there is this tracker that knows that about some nodes that actively downloading, everything will be fine. Something similar was with Nutella, Gossip, and Kaza, where people just like know something about other nodes. They can connect some of the sets of the nodes. If somebody disappears, not a big deal. Like you just connect to another one and everything is fine. The structured networks, they behave in a completely different fashion. They impose some form of a structure of which node has to connect to which node. I mean, there is some redundancy in this fashion and so forth. Like for example, in Quart, this is like very classic way. Each node is assigned some random number, like from like a limited space of those random numbers, and the node is responsible to maintain connectivity to set of nodes with those random IDs that are larger, like the next largest, and the kind of far away largest, and some other largest. And as kind of, it's also responsible to making sure that if those nodes disappear, it will reconnect to the other one, kind of to keep in the structure, so that at any given point of time, node is expected to be connected to a certain number of other hosts with a certain structure imposed on those IDs to the nodes that I'm trying to connect. Different protocols in this category simply means they behave in slightly different way of how they impose this restriction, like whether you connect kind of to 1, to 2, to 3, to n nodes, kind of in which direction of which smaller ID, which larger ID you're connecting. But kind of the logic is pretty much the same. So you impose the big structure. So if you're not kind of if interested in this part, you can certainly read the textbook. There's a very good explanation of structured peer-to-peer networks. But today's topic is mostly about BitTorrent and peer-to-peer networks kind of in general. Again, as a reminder, with peer-to-peer networks, we don't have like always on servers. Everybody just normal computers, they can be on, off, and so forth. Peers can appear, can disappear. So that's kind of the basic model of this network. To get some idea how exactly things are working, let's just do a small exercise. And this one, just to compare how much capacity we need to add to this to the network in order to support kind of X number of clients. And remember, in one of the previous lectures, I mentioned that peer-to-peer networks are kind of the probabilistic thing. And with the probabilistic, you still kind of, it's an uncertainty versus like there's quite a much certainty involved in the actual deployment of capacity as servers. But still, even with this uncertainty, you can provide a lot of service to different clients. Okay, but let's just consider this very small example. So consider just a single server with the file size of f, and like u as uplinks, d is downlinks, and s and indexes indicate the individual machines, and s is a server. So effectively, if we're trying to do the calculations, the server, if we have n clients, will effectively need to give the server and the file n times. That's inevitable. And the time to kind of send one copy, it's you divide the file size by the uplink capacity of the server. That's not a big, not a complicated problem. And simply, in order to send n copies, you have to spend this amount of time. Like you have no other ways to send the file, because it will be requested from the server. One client requested, the other client requested, third client requested, and so forth. And it actually doesn't matter whether they request at the same time, not at the same time, whether you do it in parallel or in concurrent way. I mean, it's just a difference will be either one file delivered at a time, or it will be like multiple files being delivered using the same capacity, using this packets as a chunks of the file and being distributed. And effectively, the time is determined by this equation. That's it. And if you want to support n+1 client, your capacity of the uplink needs to be increased appropriately to support those clients if you want to support them in the same time. So it's kind of, if you kind of they request it sequentially, you don't really need additional capacity. But if all of them trying to download the same file or like same size file at the same time, then you have to increase capacity in order to support all of them so they don't wait too long. A slightly different picture, and actually quite different picture, is with the peer-to-peer systems. So we still have, like in peer-to-peer system in BitTorrent, for example, we still need to, as a server, we need to share this file at least once. Until I'm telling at least one other peer that I have shared the file, nobody will know about this file. So at the very least, we'll waste this amount of time. However, the rest is quite different, because as soon as the other peer, like any other peer, downloaded your file, he can become a capacity of the network. And effectively, anybody can download whatever chunk or piece of the file either from the original server or from that secondary server. And again, like if yet another peer downloaded the whole thing, now we increasing the capacity, and kind of keep increasing the capacity. So effectively, if you kind of look at the equation here, you'll see that the time, the amount of bandwidth that you need to add to support n clients doesn't really depend on, the server doesn't really need to support that many, the server doesn't have to have that big a capacity. If you have large enough population of clients that are sharing, so all of them can act as a kind of as a proxies or the CDNs of that peer-to-peer system. And again, I don't really need to tell you more about this because you definitely have used the BitTorrent, and you saw that if we only have a handful of peers that very, very slow, then it's very, very hard to download your favorite Linux distribution. But if you're downloading some very popular Linux distribution like Ubuntu, like the latest version that is very, very hot, in that case, there's tons of peers that participate in, tons of peers that are sharing the capacity, and you can download everything as quickly as possible. So that's kind of the basic model of this. And this is just a few examples, like specific examples, how the how much you need to scale your server capacity versus the number of clients you want to support. I mean, in this model, simply saying, if you do it in a client-server fashion, it's linear equation, like linear dependency. So you want to support X, then you have to multiply X by your capacity increased by X. If you do it in peer-to-peer fashion, and for example, it's not used by only kind of BitTorrent. I think I mentioned before that games, game updates being distributed in peer-to-peer fashion for that specific reason. They don't really want to spend a lot of effort to support CDN infrastructure to just upload, to provide the upload capacity for kind of game updates, versus they can simply distribute to its internal peer-to-peer network, and every single gamer who is like actively participating in the game will be able to download and upload the game updates in real time. They may also use it for kind of other types of communication inside the game, but like some critical part like authentication, they still prefer to do it for security reasons in the client-server fashion. Again, to remind you, like a few terminology about the BitTorrent, because it's system, even though the simple system is quite simple, the protocol itself is quite interesting. And so for one part, it requires so-called a tracker. So the tracker is a quite interesting thing because it's not really participating in the peer-to-peer. So the tracker itself is a server. So the tracker has to exist. You have to, like every single peer, you have to can be able to connect to that tracker to at least to start the communication. So that's kind of one piece of that, not really peer-to-peer in BitTorrent. Then there are seeds, there are leechers. So the seeds are effectively the guys who already have the complete torrent, or like the complete file, and the leechers are someone who don't have the complete file, or they have nothing, or they have only a few chunks that not really useful for others. So it's kind of this basically model. And to what the important capacity of the tracker is the fact that it needs to exist to share with others information about others. So for example, if I just want to start downloading the torrent, I have no clue what are the peers in the system. So I'm contacting the tracker, and the tracker gives me IP addresses of the guys who part of the system. However, there's also an additional part of the tracker that it's also have information of who has what. And effectively, it will just allows you to infer to whom you can connect to download a specific part of individual file. So that's kind of the interesting part. And seeds and leechers are another part. I will talk a little bit more about the torrent, but from the security perspective. To give a little bit of credit to BitTorrent, so it was authored by Bram Cohen, and he invented the concept of tit for tat. And specifically, you are incentivized to upload. Like, because normally, like, why would you even upload if you just can download and like stop uploading anything? So the BitTorrent protocol internally, like inherently, making sure that you're uploading, not just downloading stuff. So like, because it's that, unless people uploading the whole BitTorrent, the whole peer-to-peer concept wouldn't simply work. And kind of one important concept, it's not just based on files, not the complete files, but rather smaller chunks, like a smaller pieces of the files. Like if you're sharing just one big ISO file, then this file will be just split into certain pieces. If you're sharing multiple ISO files, then sometimes you can actually, the piece that being shared within the BitTorrent will cross from one file to another file. So it's kind of, the file will be, the set of files will be considered as some kind of archive. And to illustrate what's kind of the process is happening, I guess some of this is already familiar to you. So when you join the torrent, you effectively have the torrent file. So there's additional mechanism with this magnet links, but that's a different category. This one is actually using, is built on top of the structured Kademlia network. And like internally, there's some mechanism to figure out how to go to using this hash or like random number representing the magnet link to download the torrent file. And after that, the process effectively starts. But let us forget about this part and just traditional approach that you have the torrent file, effectively describing what are the tracker, like it can have multiple trackers, and like what the description of what the files in existence and like what kind of chunks you need to download. So that's part you already know. After that, you go to the tracker, download, join the torrent, effectively giving your IP address because you're supposed to start uploading as well as soon as you get some chunks. You are getting a set of the IP addresses of other peers with whom you can download, and you can start requesting data. So the thing is, you are kind of depending on what state of of others, others may have different options whether they give you the data you're requesting or not giving you data you're requesting. And this is where this tit for tat is coming from, or coming in. If the system is working, like there's some new torrent file just appeared, unless you upload, you're not being given a priority to download. There's a little bit of a description in this on this slide, but effectively, as kind of, you're still getting some probabilistic way of start downloading, so-called optimistical unchoke, like mentioned in the last bullet here. But until you get this optimistical unchoke, nobody will give you data, because like nobody knew that you have uploaded. So kind of, you upload is your credit for the future download. As soon as you start uploading with the individual, then you kind of gaining some credit with the other peer, and that peer is more willing to give you more chunks to download. Like, it's, instead of just doing this optimistical unchoke, it's actually unchoke you and start giving you files. You cannot do it too much, because as soon as kind of the balance is you exit the balance of how much you uploaded to that peer and how much you downloaded from that peer, then that guy may decide to choke you again. And then you still have to wait for this optimistical unchoke and kind of start sharing with that guy and being able to download stuff. I don't know, depending on which torrent system you're using, some of them still have the ability to see what is your ratio between upload and download, and that's for exactly this reason. Because as long as your ratio is good, then you have a very higher chance to get information from others, versus if you don't upload too much, then you have very, very small chance to download files. So this one doesn't really apply for the very popular torrents. So the ones that already kind of established ones, like the same Linux distribution that I'm keep mentioning. And it's really active only for something that is very, very new. So for example, if you're talking about game updates, so this one is being just pushed into the system and everybody wants to get it at the same time. So in that specific case, you want as much capacity to be brought into the system. So you want everybody start uploading as soon as they download the items. So this is where this tit for tat system is kicking in. Additional thing that I would like to mention about BitTorrent is it's very strict security. And it's like really, really, and security in the context of downloading the right thing. So the reason BitTorrent has this very, very strict security model is because you can download file from anybody. And if everybody can serve the information, you no longer have ability to do kind of HTTPS style kind of securing of the channel. Because if you try to do that, now you will have to give certificate to every single peer. And if like everybody have the same certificate, the same private key, now there's no security associated with this one, because kind of if some other peer have the certificate and like, it doesn't really behave correctly, like instead of serving you good file, it's a good chunk of the file, it's sending some garbage, then kind of nothing good will happen. So what the BitTorrent did right is, in addition to just chunking the individual, kind of chunking the file in the individual pieces and identifying those pieces by some numbers or IDs, they also associated with each piece of that file or each chunk, they associated the cryptographic hash. And this hash effectively kind of almost uniquely identifies the content itself. So it's kind of, there's a very, so effectively what is kind of, if we can look it up, what hash algorithms, and maybe we can talk about this in the last module. Effectively, you have like 200 kilobytes of content. You can run this cryptographical algorithm and produce a 32-byte kind of number that has extremely high chance of not being the same for any other piece of data. The probability of the collision is extremely, extremely small. So kind of almost basically negligible. So with that, like when you have a list of chunk IDs, chunk hashes, it doesn't matter from where you download the specific chunk. You can download it from me, download it from anybody else in a class, and as soon as you download the chunk, you calculate the same hash over the content you just received. If it matches the one that is specified in torrent file, you can be sure that yes, that's what was intended in this torrent file. So it's kind of, in this respect, this is very, very strict security model. Like whenever you download something, you know for sure that this is the thing was intended to be downloaded by you. This model doesn't really exist in HTTP, in all the FTP, and sometimes people actually posted like .md, .sha file kind of to check the validity of what you're downloading. I don't know whether you have experienced this or not. With HTTPS, the problem is a little bit better, but it's not guaranteed that the information that you retrieved over HTTPS protocol, the file you retrieved, is the one that is intended to be retrieved, because there's no additional checks as part of the what is the content of the file that you're retrieving. Versus if you're using BitTorrent and have so-called write file, and I'll try to talk about this more in a second, you know for sure that you downloaded the right stuff. So the key concept here is the right file. The strict security here doesn't really mean that you always will download what you want, that is the correct Linux distribution that you want to download. It really matters of what is this torrent file. Somebody can easily create a fake torrent file, and instead of Ubuntu put like Fedora, or like instead of Ubuntu like be very creative and put Windows ISO. So this happens, and you'll be very sure that each individual chunk that you're downloading is the one that was specified in this fake torrent file, and you end up downloading the fake content. But kind of you still have to figure out what is the correct torrent file. And if you know it's the correct one, like either you peer told you that, oh yeah, that's the correct one, or like I told you something, or like you discovered on the internet that it's the correct file, then you can be sure that that's the correct one. But there is still a challenge to figure out what is the correct thing. And to summarize, peer-to-peer networks is a quite interesting mechanism to increase capacity of whatever data distribution that you would like to provide without actually creating new servers or adding the capacity to the servers that you have. And we have like several very famous examples of the peer-to-peer networks. One of them is BitTorrent, the other one is Game Updates, and I think they're also using some form of a BitTorrent as part of this protocol. For what I want to remember for the BitTorrent, remember about the tit-for-tat process. The fact that you are incentivized to upload by not giving you download if you did upload. So it's kind of, until you start uploading, nobody gonna give you to download file, but this with the asterisk that sometimes they will give you in order to actually bootstrap the process. Otherwise, it's kind of chicken and egg problem. Like you still have to download something in order to start uploading. And the torrent has a very good security model with respect to the content, because if you get the right torrent file, then you can be sure that you got the right content for this torrent file. The one that I would like to kind of think a little bit about the question that I put on a slide is can you be tracked? And what kind of ways you can be tracked as part of this torrent process? This is as part of the warning, as part of our discussion. So let me put this question as broad as I just defined. Like, just think of the model of the tracker that you have to go there. Like every time, you actually have to periodically contact the tracker in some way. And sometimes this tracker is HTTP-based protocol. So maybe you can already figure out how you can be tracked. But think about this one, but there's also some kind of a tracking may or may not be available as part of the actual protocol. I'll stop here and give you some opportunities to think and write the answer about this one. Okay, so thank you and hope to see you soon.